In this video, you are going to understand parallel combination of cell. If you have two pencil batteries, this is positive and this is negative. This is positive and this is negative. Then connecting these two battery like this, keeping one above another, and just connecting these two ends to a wire and these two ends to a wire is said to be a parallel combination. This is also a parallel combination, but this is in opposite polarity. Let us see what will be the equivalent EMF and equivalent resistance when the cells are connected in parallel. Here for parallel combination, I am taking here two cells. This is cell number 1 having internal resistance R1 and EMF of the cell is E1 plus minus. Let us take another cell of internal resistance R2 and EMF of the cell is E2. Here is positive, minus, plus and minus. Connect these two cells together to form a parallel combination. Connecting along a external resistance. No need for this, only you join like this the circuit. Let this point be A and this point is B. So current from this EMF will I1 cell and current from this cell is I2. So at this junction we have current I, which is equals to I1 plus I2. This is said to be cell 1. Cell 1 have EMF and internal resistance. Cell 1. This is said to be cell 2. It have cell 2. Now let us draw the equivalent EMF. Equivalent circuit EMF. So this is R equivalent, this is E equivalent, plus and minus. Here you have point A and here you have point B. The current is I. Now this is the circuit diagram. In this circuit diagram we are saying that current I is equals to I1 plus I2. So we will write in parallel combination I is equals to I1 plus I2. You know that E equals to V plus IR. So from here you have I is equals to E minus V upon R. We will using this information here. For I, we use the equivalent circuit. So at the place of I will write at the place of I will write E equivalent minus V upon R equivalent. And at the place of I1, I will write E1 minus V by R1. At the place of I2, it is E2 minus V by R2. V is common here because these two cells are in parallel combination. So potential difference along the cells are same, which is V. Same for here also, this is also V. Now arrange it. So this is E equivalent upon R equivalent minus V upon R equivalent. This is E1 upon R1 minus V upon R1 plus E2 upon R2 minus V upon R2. We can write the equation as E equivalent upon R equivalent minus V upon R equivalent is equals to write this E1 by R1 and E2 by R2 in a bracket, E1 by R1 plus E2 by R2 in a single bracket, give a minus sign, take minus V common. So we have 1 by R1 plus 1 by R2. Now we are going to compare each term of LHS and RHS. We are going to compare each term of LHS and RHS of this equation. So I will write comparing each term of LHS and RHS. we have what we have? We have E equivalent by R equivalent. E equivalent upon R equivalent is equals to this term. This is E1 upon R1 plus E2 upon R2, and second is minus V by R equivalent is equals to minus V 1 by R1 plus 1 by R2. Cancel this. So you have 1 by R equivalent is equals to 1 by R1 plus 1 by R2. This is the equivalent resistance here, and this is the equation for equivalent cell. Let this be equation number 1, this be equation number 2. Now from equation 1 we have E equivalent by R equivalent is equals to LCM is R1 into R2, and here we have R1 R2 plus E2 R1. Let this be equation number 3. From equation 2, 1 by R equivalent is equals to LCM is R1 into R2, and here we have R2 plus R1. This is equation number 4. Now use equation number 4 in equation number 3. We are going to use equation number 4 in equation number 3. So what we get? We get E equivalent into, here 1 by R equivalent equal to this quantity. So at the place of 1 by R equivalent, we will write R2 minus R2 plus R1 divided by R1 into R2. On RHS the term is same, R1 R2 plus E2 R1 divided by R1 into R2. We cancel these denominators. So we have E equivalent equals to E1 R2 plus E2 R1 upon R1 plus R2. This will be the equation for equivalent cell in parallel. This is the equation for equivalent cell in parallel. But if you have n cells, then you can write like this. For n number of cells in parallel, we have E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2 plus dot 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 plus En by Rn, and 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus dot dot 1 by Rn. This is said to be equivalent EMF and equivalent resistance when the cells are connected in parallel. Let us see numerical based on this. Let us understand a very good numerical based on this. I am taking two cells in parallel. This is cell 1 with internal resistance, cell 2 this is internal resistance. Let both are connected parallelly. With external resistance, here plus minus. So this is in parallel having same polarity. Let the value of R is equals to 5 ohm, and this is said to be E1. E1 equals to 1.5 volt. This is R1. R1 equals to 0.2 ohm. This is E2. E2 is 3 volt, and this is R2. Let R2 is 0.3 ohm. You have to find the current I. What will be the value of current I in this circuit? You have to find the value of current I. So for finding current I, first of all we have to find the equivalent resistance and the equivalent EMF. Equivalent EMF, E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2. You know this equation. And also you know 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Better you have using this equation here. So we know these two formulas. So number first, to find out the R equivalent, 1 by R equivalent is equals to 1 by 0.2 plus 1 by 0.3. From here you can write this is 10 by 2 plus 10 by 3. From here the LCM is 6. Take 10 common. So you have 3 plus 2, which is 5 plus 3 plus 2 is 5, and 5 into 10, 50 by 6. So R equivalent come out to be 6 upon 50 ohm. If you need, you can solve further also. This is 3 by 25 ohm. Now we are able to use R equivalent here. Now E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2. This means that we are writing E equivalent here, and at the place of R equivalent you write 3 upon 25. At the place of E1 is 1.5, right here 1.5. At the place of R1 write 0.2. At the place of E2 write 3. At the place of R2 write 0.3. So here you have 15 upon 2, eliminating the point, plus 30 by 3. So here you have this is LCM is 6. Take the common term is 15. Here you have 3, and here you have taken 15, so here it is left 2 into 2 is 4. So you have 15 into 7 upon 6. Solve this. This is 7 upon cut this is 3 2 and 3 5. So 15 into 5 upon 2. So what will the value of E equivalent? E equivalent is equals to 7 into 5 into R equivalent, or we have written the value of R equivalent, don't worry. We know the value of R equivalent is 3 upon 25. 3 upon 25, and the denominator side is 2. Cut this 5 with 5. So 7 into 3, 21 upon 10. This is 2.1 volt. The voltage you get 2.1 volt, but you have to find the current. Current I. We know the equation for current I is equals to E equivalent R, capital R, by small r equivalent. So what will be E equivalent? We have just find the value of E equivalent is 2.1. Place the value 2.1. Write the value of R, which is 5, and write the value of R equivalent. R equivalent, just you have determined R equivalent. R equivalent is equals to 3 by 25. So this is 3 by 25. Only you have to solve this. So here you have 3 divided by 25, it is 2.1, and 5 plus 0.12. So you have 2.1 divided by 5.12. So 5.12 divided by here 2.1 divided by 5.12, it's come out to be 0.41 ampere. So the current is 0.41 ampere. Thank you, students. If you understand what is a parallel combination of cell and you want notification of my channel, you must Subscribe my channel and press the bell icon for notification. Thank you.